Okay, so page 315, number 25. We have Claude and Heather, and they're skating in the same direction, but Claude is behind Heather. And it says Claude's mass is 72 kilograms, and Heather's mass is 47 kilograms. Okay, so the question says Claude and Heather are practicing pair skating for a competition. Heather, 47 kilograms, is skating with a velocity of 2.2 meters per second. So initial velocity of Heather is 2.2 meters per second. Claude, 72 kilograms, directly behind her, skating with a velocity of 3.1 meters per second. Whoops. V of Claude initial, 3.1 meters per second. When he reaches her, he holds her waist and they skate together. So when he catches up to her, the collision, in quotes, is him taking a hold of her waist, and they go off with the final velocity, and that's what we're looking for. Okay, so it's going to be M of Claude, V of Claude initial, plus M of Heather, V of Heather initial, is equal to, and after the collision, now you could write it as M Claude, V Claude final, M Heather, V Heather final, but since they're joined together, that's the same thing as saying M Claude plus M Heather, V final. Whoops, put the bracket here. And then you want to solve for this V final, so divide by the M Claude plus M Heather, and bringing it down here. So we have V final is equal to M of Claude is 72 kilograms, V initial 3.1 meters per second, plus M of Heather 47 kilograms, V of Heather 2.2 meters per second, and then divide by their combined mass, 72 kilograms plus 47 kilograms. And when you do this, you get a VF of 2.74 meters per second. Works out to be positive. Everything's going in the same direction, so after they join, they too continue in that original direction, whichever way it was. Number 26, you have two cards. Two amusement park wrecker cars are traveling directly towards each other. The combined mass of car A plus driver, 375 kilograms. This is A, and it is initially traveling 1.8 meters per second. B, combined mass is 422 kilograms, and it is initially traveling negative, because it's the opposite direction, so they don't tell us east or west, they just call it a negative, 1.4 meters per second. After the collision, they are joined together and they go off in some direction with a common final velocity, and the question wants to know what is that velocity. So again, MAVA initial plus MBVB initial is equal to MA plus MB V final. I'll bring it down here. So V final will equal MAVA initial plus MBVB initial divided by MA plus MB. A was 375 kilograms times 1.8 meters per second plus 422 kilograms times negative 1.4 meters per second. And then divided by 375 plus 422. Okay, and when you do this, you get a V final to be 0.106 meters per second. Works out to be positive, which means it's in the direction of A. Okay? All right, now turn the page, number 27. 27 is a cannon on some kind of a platform that has wheels and has a ball, and it's going to shoot the ball this way. Okay? So initially they're both at rest, and so it says the mass of the cannon is 1385 kilograms And the mass of the ball is 58.5 kilograms. And it says it fires the ball, so the V of the ball final is going to be 49.8 meters per second. And it says that it fires it north, so this is north. And it wants to know, so what will be the final velocity of the cannon? Okay, so m of the cannon, v of the cannon initial, plus m of the ball, v of the ball initial, will equal m of the cannon, v of the cannon final, m of the ball, v of the ball final. Initially, they're both at rest. It's a lot easier to fire a cannon if it's not moving. All right, and so you're going to bring one term over and it become negative. And then divide by the mass of the cannon because you're looking for the velocity of the cannon. So m of the ball, v of the ball final, and don't forget your negative sign. I'm just going to put that negative sign out in front. So ball was 58.5 kilograms. The speed was 49.8 meters per second. And the cannon was 1385 kilograms. And so when you do this, you get negative 2.10 meters per second. And what the negative means is south, because it told us the cannon was going north. All right, number 28. 28 says, while you're wearing inline skates, so here you are, and you're on a pair of skates, and you're on these skates so that you're going to fire a rock. And so when you fire the rock, if you weren't on skates, friction would stop you. But being on inline skates, then you're going to move backward. So it tells us the mass of the rock is 1.7 kilograms, and your mass is 57 kilograms. And so you're standing there with the rock initially, and now you fire it. So you throw it directly west with a velocity of 3.8 meters per second. So V of the rock, and it's going to be final, is 3.8 meters per second west. And so, of course, you move off in the opposite direction, so V of the person final is what you're looking for. And the initials are 0 because you're just standing there. So M of the person, V of the person's initial, plus M of the rock, V of the rock initial, will equal m of the person, v of the person final, m of the rock, v of the rock final. Both initials go to 0. Bring one term over, minus m of the person, v of the person final, equals m of the rock, v of the rock final. Solving for v of the person final, so divide. So rock, negative person. Fill in your numbers. So 1.7 kilograms times 3.8 meters per second, and in this case I'm calling west positive because I didn't put a negative in, and then divided by 57 kilograms and the negative from rearranging. So it works out to be, for the person, negative 0.113 meters per second. What does the negative mean? In this case, it means east, because I called west positive. So had I wanted to call west negative, I would have put a negative on my 3.8, and the two negatives here would have canceled each other out, and my answer would have been positive, and that would have been east, because I called west negative. But since in this case I called west positive, my east means negative. Okay? Final answer. Hopefully these are pretty good, and now it's time to work on your assignment.